Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will see the topic on Boolean function for the course Digital System Design. So a Boolean function is described by a logical expression and which consists of the binary variables, zeros and ones, and also the logical operation symbols. So for example of a Boolean function is f is equal to x y dash into z plus p. So here the Boolean function is given in terms of four binary variables x, y, z and b. So this is known as a Boolean function. And now, in order to obtain a logical function reduction, we need to simplify the Boolean function using Boolean theorems and also Boolean laws. So, this is called Boolean function simplification. So, this is need to do because to reduce the number of logic gates used and also to reduce the power consumption and system complexity. So now we are going to see some examples of how to reduce the Boolean function using Boolean theorems and laws. So for the first example, the problem 1 is taken as AB plus A bar C plus BC. So this can be reduced into AB plus A bar C by using Boolean laws. So the three terms is reduced into two terms. So we can reduce the number of logic gates used in the design. So the first example, the left hand side terms are taken, and in the third term BC, what we are doing is we are multiplying with 1 because according to AND law, any variable can be multiplied by 1 is equal to the same variable. So BC is multiplied with 1. And in the next step, this 1 is replaced by A plus A bar because we have only BC in the last term. The missing variable is A. So in order to insert the missing variable, we are adding instead of 1 as A plus A bar. So according to R law, any variable added with its complement gives this a value equal to 1. So A plus A bar is equal to 1. So in the third step, the third term, we are multiplying inside. So BC multiplied with A is ABC. BC multiplied with A bar is BC A bar. And now we are combining some like terms. So for example, the first term and third term is taken. AB is taken and the remaining is 1 in the first term. In the third term, the remaining is C. Similarly, second and fourth terms are combined as A bar C into 1 plus B. So now it is AB plus A bar C. So we see the second example. Second example is the A plus B bar multiplied by A bar plus C multiplied by B plus C. So this can be simplified into two terms by A plus B into A bar plus C. So for example, the left hand side is taken and what we are doing is in the third term we are adding 0 because according to our law, if we add 0 to any variable, it is equal to the same variable. So A plus B, A bar plus C into B plus C, the 0 is added in the third term. So in the next step, instead of 0, we are giving A bar because if A bar gives the value 0 because any variable multiplied by its complement value gives 0. For example, if you take A value is 1 and its complement is 0, 1 into 0 is 0. Suppose if A value is 1, if we its complement is 0, 1 into 0 is also 0. So in this way, we can give instead of 0, A bar. And in the third step, according to distributive law, we can write B plus C plus A bar as B plus C plus A into B plus C plus A bar. And similarly, in the last step, the like terms are combined and finally we give the result, get the result as A plus B into A bar plus C. So this is according to absorption law, A into A plus B is equal to A. And in the next example, the Boolean function is given as y is equal to a bar b bar c bar plus a bar b c bar plus a b bar c bar plus a b c bar. So here a bar c bar is taken from the first term and also second term. So the remaining is b plus b bar. Similarly, the last two terms are combined. A c bar is taken, it is b plus b bar. So we know that any variable with its complement, if we add both this, we get the value equal to 1. So b plus b bar is equal to 1. The remaining in the third step is a bar c bar plus a c bar. Now in these two terms c bar is taken, so the remaining terms are a plus a bar, it is equal to 1. So c bar into 1 is equal to c. So in this way we can finally reduce these many terms into a simple term c bar by using Boolean theorems and Boolean algebra. So now the assessment, the Boolean function. Boolean function, we know it is an algebraic function having the variables and also zeros and ones and the logical terms. And the next is the need of simplifying logical expression is to reduce the number of logic gates used in the design and to reduce the power consumption by this logic gates, and also to reduce the system complexity we need to simplify the logical expressions and reducing the number of gates. And next is Boolean algebra is used in logical function reduction, and so that we can reduce the number of gates used. So in this way we can easily obtain the Boolean function and also the reduction of Boolean function. So thank you.